Hi chemistry family, we are going to be going over balancing equations, and I wanted to walk through a couple examples with you to make sure that you're feeling confident and comfortable. So the main goal here is when we see the arrow, that really means an equal sign. It means that all the things that come before the arrow, which we know are called the reactants, are what are going to combine together and actually react in a chemical equation. Now after the arrow, those are the things that are going to come out of the reaction, and we call those things that come out of the reaction, it's the same as the answer to a multiplication problem, we call those the products. So we have two sides of a chemical reaction. Let's get going on how to balance them, because whatever we start with, we have to end with. That's because of what we call the conservation of matter. The matter has to be accounted for. It just doesn't react and then disappear. Things get broken apart, rearranged, but always we can account for where everything went. And that's why we have chemical reactions and why we have to balance them. All right, so let's actually balance this out. On this side, we have 1 sodium and 2 oxygens, all right? 1 sodium and 2 oxygens because of that subscript 2 on the oxygen. Now over here, we already have 2 sodiums and 1 oxygen. So we're not balanced. So we have to figure out a way to balance them by using what we call coefficients, which are these big numbers that we've been practicing with. All right, so if on this side, and let me change my color here to black, if we have 2 sodiums on this side, I need to make it 2 sodiums on that side. To do that, I'm going to put a 2 here. What that is going to do is now make that 2 sodiums, which means sodiums are balanced out. Now that would be good, except there's 2 oxygens over here and only 1 over here. So unfortunately that didn't work, because we're going to have to put a 2 over here to give you 2 oxygen, but that's going to end up making 4 sodium. All right, so this happens sometimes. We're going to have to start over a little bit. And the reason I want to show you that is because these things do happen sometimes. So let's start over again. If there's 2 oxygen over here and only 1 over here, if I put 2 over here, not only does that 2 distribute to the sodium, but also distributes to the oxygen. So 2 times 2 sodium is going to give me 4 sodiums on the product side. And 2 times 1 oxygen is going to give me 2 oxygen. All right? I already have 2 oxygen on this side. So the good news is my oxygen is now balanced. But now I have 4 sodium on this side and only 1 sodium on the reactant side. So that means I'm going to need to make this 4 sodium on the reactant side. If I do a coefficient, the big number of 4, that is going to be 4 times 1, which will make this sodium 4. Are they balanced now? Yes, they are. What about this blank spot in the middle here? We could leave that blank, or technically you could put a 1 if you wanted to. But leaving it blank is totally fine. But in the end, everything on each side of the arrow is equaled out. You have 4 sodium plus an oxygen molecule, right? Ends up being coefficient of 2 with the sodium oxide. And again, everything's balanced on the reactant side and the product side. All right, let's try number 2. So right now, on the reactant side, we have 2 hydrogens and 2 oxygens, right? These little subscripts tell you how many of each. And on the product side, we have 2 hydrogen and we have 1 oxygen. So now we have to find a way to balance it on each side of the arrow. Remember, the arrow is almost like an equal sign. Okay, so 2 hydrogen and 2 hydrogen are pretty much balanced. So that means we need to try to balance out the 2 oxygen with the 1 oxygen. To do that, I'm going to use the big number coefficient 2. By doing so, that 2 is going to give me 2 oxygen. But because it's also attached to a molecule, it's going to give me 2 times 2 hydrogen, which is now going to give me 4. Now on the reactant side, I already have 2 oxygens, so that's good. My 2 oxygen are canceled. But I only have 2 hydrogen and I need 4. So to balance that out, I'm going to put a 2 at the top. By doing that, 2 times 2 hydrogen will give me 4 hydrogen. And 4 hydrogen on the product and reactant side means it's balanced. So that means my final balanced equation is 2 hydrogen gases plus an oxygen molecule gives me 2 molecules of water, H2O. Again, notice I didn't have to, but I could have put a 1 in front of there if that makes you feel better, though technically you don't have to do that. But now it's balanced. Looking at number 3, let's kind of break this all down. We have 2 sodiums. And if you look at SO4, if you remember, SO4 is a polyatomic ion. So when I deal with polyatomic ions and they're on both sides of the equation, I like to keep them all together, stuck together. So that means I have 1 SO4 on the reactant side. Also, I have 1 calcium and 2 chlorine. Okay, so we break that in half. Now on this side, on the product side, I have 1 calcium, I have 1 sulfate. Remember, I'm just keeping that all together. You don't have to, but it makes the balancing a little bit quicker. All right, I also have 1 sodium, and I have 1 chlorine. All right, so let's see any imbalance here. We've got 2 sodium and 1 sodium, so we got to balance that out. 2 chlorine and 1 chlorine. And everything else seems balanced. Calcium and calcium are balanced, sulfate and sulfate are balanced. Okay, so we need to get 2 sodium and 2 chlorine on each side. Well, that's pretty easy. If we drop a coefficient of 2 in there, that gives me 2 sodium and 2 chlorine because 2 times 1 is 2. So now I have 2 sodium and 2 chlorine instead. And that means my 2 sodium and 2 chlorine cancel out. Those already canceled out. I have 1 calcium on the reactant side, 1 on the product, 1 sulfate on the reactant side, and 1 on the product. So I actually am balanced. So when I balance it out, it's just a 1, 1, 1, 2 for my coefficients. Pretty straightforward. All right, and let's try number 4 together too. So I'm going to split this in half. Remember, my left side of my arrow is my reactant side, and it looks like I have 2 aluminums and 3 oxygens. On my product side, I have 1 aluminum and 2 oxygens. Remember, these little numbers, the subscripts, tell you how many of each atom you have. All right, so I have 2 aluminum, 1 oxygen, that needs to balance, and I have 3 oxygen and 2 oxygen. All right, so to get 3 and 2, because we do everything by multiplication, it looks like these are both going to end up needing to be 6 oxygen. Why? Because 2 and 3, the common factor between them ends up being 6. So I'm going to try to make each oxygen 6 since those two numbers are so different from each other. So on this side, the product side, I'm going to put a 3 because 3 times 2 oxygen will give me 6. And on this side, I'm going to put a 2 because 2 times 3 oxygen is going to give me 6. What that does is cancel out my oxygens, but in the meantime, that 2 also affected my aluminum. Now I have 4 aluminum because 2 times 2 aluminum is 4. So if I have 1 aluminum on this side, I'm going to need 4 aluminums. And to do that, I'm going to put a coefficient of 4. By doing so, that gives me 4 aluminums and 4 aluminums, and I'm balanced. Remember, you have to have the same number of each type of element on both sides of the arrow. It has to be balanced because of what we call the conservation of matter. Whatever matter you start with on the reactant side, you have to end with the same amount. Even though it's rearranged into something different, you still have to have the same amount accounted for on both sides of the arrow. That's again to show the conservation of matter. Well, hopefully this helps a little bit, ChemFam. Keep on plugging away, and with practice, you will get better and better.